welcome you all for this presentation. Thank you for your interest and joining this webinar. Today we are going to explore yet another important building system, which is steel structures, right, in ETABS. And this presentation is specifically designed for those new to these steel structures. We will guide you through the recommended practices for defining, modeling, analyzing, and designing of steel members. And for this presentation, we will use a typical shed model, which will cover most of these features of the software, and you will be able to demonstrate it. So before we enter into the ETABS, where we will be discussing many of things, but I want to highlight the features of the program through the slides, and then we will move to the example model. Now, those who have acquaintance with this program may find it very easy, but for those who are new, I think we would like to cover their requirements too. So we are discussing from basics to all the definitions that are needed for the modeling and analysis and design. Right, starting from the definitions, we will define a grid system and we will define the properties, and we know the problem in hand, so we also define the loading, so the load patterns for gravity and lateral, and we also add additional load cases for response spectrum, and we also consider a stage construction case for capturing the bracing effect only for the lateral loads. And we also have the load combinations. It can be user or auto. And in the drawing, we will be using various tools, assignments, and editing tools in creating the required steel structure. And then for the analysis and design, we have certain definitions, and specifically for the design, we have preferences, overrides, etc., which will also be covered. So we have the P delta effect, which the program is capable of capturing either through the analysis or through the approximate method given in the code. So we have both the global lateral translation, P capital delta, and then the member buckling, P small delta effects, right? So the recommended way is you do the P delta analysis, and then the local bending effect is captured through the conservative design process. However, if one wishes to model the local effect, can introduce joints in the frame or break the elements, that will also do. And in the modeling, we prefer a single element than breaking the elements into multiple segments of a same member, like a column or a beam. You need not. However, even if you break, program can handle this, but there will be effect on the factors that are calculated automatically by the program, which should be taken care. So I have left a lot of explanation in the slides, which we can refer to later in the session. And then the design procedure, go through certain steps. So from the analysis and design prerequisites, it will obtain like effect length factors, forces from the analysis results, right? And then it's add with the section classification. and then uh, factored strengths of the members or cross sections, right? And the combined forces that will finally provide the interaction ratio, which is demand capacity ratio for the final one. And additionally, special seismic provisions also covered as per IS 800 2007 code. So this slide explains the same. And then there is an unbraced length ratio, which can be crucial in your design. So there are three sources for determining the unbraced length ratio. With increasing priority, this is listed here. One is automatic calculation, which program calculates from the member connectivity. The other one is precise bracing, which the user will have to model the bracing points. Then program can recognize those bracing points. And then you also have the overwrites. You can directly overwrite unsupported length ratios on a member by member basis. So all three are possible. So you can utilize the one that suits your requirement. And the other one is the effective length factor, right? So effective length factor for non-sway and sway are automated in the program. So you can leave it to the program can do it. But however, when you perform a P delta analysis, so it assumes that no further sway, then assumes the frame is non-sway and the K value will be set to unity. So this is similar to the RCC buildings you would have used. And you also have the override option on member by member basis, which you can always do. And then we have design load combinations. Program is capable of creating the static loading conditions, load combinations. So the standard load factors are listed here. You can also define your own combination and include it in the design combination list. So it can also handle notional loads, can also handle multi-valued combinations such as response spectrum analysis. Program creates sub-combinations using the maximum minimum values of the interacting forces. That is, 8 sub-combinations will be generated for each combination used in the design. And then it also handles the live load reduction. For this example, we will not use these. Next, in the design, we have two approaches. Analysis section versus design section is a topic that covers this. So typically we will be modeling the structure as usual and assigning the member properties, the section properties of the frames. A single section property is assigned. The program sets both analysis and design section to that same property, right? And then you have the option to assign auto select list. Then program initially uses a section with a median weight from that list for both analysis section and design section. And when you perform the analysis and then you perform the design, program completes the design if it is of single property and gives you the results. But when it is an auto select, then it enters into the iterative process, which is highlighted in blue. So it will select a different section during the design process, right? And then it will also prompt you that the sections differ after the design. So it will prompt you whether to iterate again with the new selected section for the design as the analysis section. If you press yes, program performs it. Another iteration. The iteration can go a couple of times or more than that to arrive at the final completion. The design process is considered complete when the analysis section and the design section are the same. You can choose to terminate this iteration and specify member section properties manually, and then you can exit at any point of time. So it is a optimization process which program handles it for you. And for the special seismic provisions, I will not get into the details, but it takes care of the special load combinations and the member design of particular frame type for different zones, etc. And it will prompt you with messages when it is not fitting that design request for that particular zone. It also covers the joint design. We will not be discussing the joint design in this example. And then we have overwrites, specifically for steel frame design. We can change the design procedure from a steel frame design to a composite. The program allows. So in this example, we'll not be using it, but for a steel building system, right, typically with decks and beams. So the composite action for that design, it allows you to override the design procedure. And also, there are default values when you start the design. Default values are provided for all override items. So it is not necessary to change any of them unless required for a specific design. So assignment is when you assign something, and then the persistence means that changes made through overrides are applied only to the members to which they are specifically assigned. And override values are not lost when the model is unlocked or when design combinations or preferences are altered. So you will have to reset the overrides basically to begin afresh. Okay, let's move to the ETABS and let us discuss the modeling. So in the ETABS, we will start a new model. We will start from scratch. I'll spend some time in the modeling session. We'll set up with the metric SI Indian code for steel, then press OK. Right. So the grid system. So how we are going to define this grid system is, so it's a single story shed type. Even if it has mezzanine, you can still consider it as a single story and then model the members accordingly. So in mezzanine level, you can create another level within the story and create the objects there. So program helps you on that through the grid system definition through reference plates. Now, for this building, it is 5 by 5. I mean, five spans of 5 meters in the longitudinal direction and a double sloped roof of 16-meter span, 8 meters and 8 meters. And then I will create the grid system accordingly. So what I will do is for the X direction, it will be the shorter direction of the building. So I'll put 5 grid lines. It will make 4 spans of 4 meters. Total will be 16. And then next grid lines for the Y direction, it will be 6. For X direction, it is 4. And Y direction, it will be 5. You can see this plot. And then for the story, we can put two stories, one for the base plate level to the eaves, and then the eaves to the ridge, another story. Typical story height can put 1.5, and then this one has 8 meters. You can model the pedestal part of the structure, but as I discussed earlier, the program will utilize the member properties, the stiffness, rotation stiffness of these members to calculate the effect length factors. You will have to overwrite in your design. So you can decide on that. We quickly edit this. Let's call this as eaves at 8 meter and then ridge 1.5. With this, we have created the grid system. Save this. Steel shed. I'll save this model once, and then we will continue with the other definitions. Now, under the define, you'll define the material properties. So default Fe345 is available. We can utilize this, or you can add new material or steel, say up to 50. You can have this as well. Next, under the section properties, you have the frame sections and the roofing sheet. We'll define these two. But under the frame, we'll define several sections. So I'll show you. I'll delete existing select list. So we have the import new properties from the library. Standards, let's start for the columns and beams. It will be of I section, Indian standard. This is located in the installed location of the program. You can see this property libraries, and you can select the region-based property file, and then you can include. I'm keeping it Fe345 as a material property, and I will import, let's say, ISMB 200 to 500. And then I'll also import some channel section. ISLC 75 to 200. And then for the braces, we'll also import some pipe sections. Say about some 40 to 80. These are imported to the model database. From here, we will create the auto select list. We will use that approach. Let us define auto select list. You can see this under the special, or you can always find it under the list, auto select list. Let's define for the columns. So this step is going to help you significantly in your design process. So bear with me. I'll quickly finish this. So ISMB till 500. me also label this so that I can easily identify as an auto select list by prefixing A before the section name. We'll add one more for the rafters. We also have the same set sections similar to columns. A few more. One is for the purlins. Purlins will use channel section. One more for Girts. Same channel section for that too. And you can see the starting section when you use this auto select list, median section by area or by the weight, other words, used as the analysis section, the first section before any iteration. Later, the iteration will happen as you perform it during the design. All right. Then last definition for the braces. Braces will use SNB. All right. You save this. So next definition under section properties would be the slab section. We'll have the roofing. As a steel membrane, you can have the one-way distribution and the thickness of 2 mm. All right. Next, we will start creating the members. So for the modeling, we will switch to the elevation view. Before that, I'll also set the graphics font size a little bit. Also enable show bounding plane, and can get the views under the view menu. I will be using the shortcuts, elevation, grid 1, right. Let us draw the columns first. And I will select the property A col and create the n columns first. And then I will use 2-point click option. This time will be for the rafters. And then we'll also add the wind columns for the y direction. So I'll use the columns again. On the ends and columns on the above level as well. We'll have to trim this. So select and then use edit, align, trim. So the columns will be till the rafter. Right. So next we'll be creating the purlins and the roofing sheet. So for that, for the modeling purpose, I'm going to divide these beams. So edit frames, divide into this many segments, or you can also break it in other ways. I'm going to use 8, so 1 meter center to center for the purlins. Then you can see these are divided. We'll select these broken elements and the joints, and then I will start using the extrude option. Extrude joints to frames. This is to create the purlins in y direction. So notice 5 meters. I'll put dy equal to 5 and 1 time. I'll get the previous selection. We'll go to next item in the extrude, which is extrude frames to shells. Again, linear in y direction, 5 meters, 1 time, and apply. So after completing this, you can select it. Select these members back and use frames to join these once again. So join will give us back the same single frame object for these rafters. All right. Now let us work with the other frame, the second frame. We'll simply edit and use replicate command to create 5. Right, you can see wind columns are left only for the end frames for the y direction. And for the purlins, I will have to select these and assign them with frame section properties, add purlins. Right. And then we'll get the previous selection and assign shell roofing. We'll select this once again, and these will be released for end moments. So we'll assign frames releases. We'll release them for both M22 and M33 moments. Apply this shells with some loading. Okay, we'll come to the loading shortly. Let me finish other modeling item, which should be the Girts frames, which will be on the periphery of the building all around. So to create the Girts, it will be the similar way. through the extrusion, but we need the joints along the height of these columns. So any one column is sufficient to start with. One option is to break this column and create, or the other option is to draw the joint objects directly with some offsets. So this would be useful when these heights are different. Just want to demonstrate that. So it is in mm, so is the direction 1000. Right, is sufficient. I'm keeping it uniform at 1 meter. Select these and use the extrude frames X direction 4 times, 1, and then number of times also you can specify directly here 4 times. Oh, I'm sorry. It should be 0. Right, it's done. And these will also be released. I'll select all of these and assign them with releases. And then I'll select this. First bay and use replicate command to replicate this in other bays 1, 2, 3, and 4, 5, and then 4 times. And then select these members and replicate it on the other end of the building. So that will be 25, 1 time, done. Also create girt frames for the y direction, the longer direction. And use edit, extrude. It's in y direction 5 and 4 times, 5 times, sorry. Right. Next, what you can do, you can select all the beams. We have various selecting tools. Right. And then we'll also deselect the moment frame that are the rafters. Deselect, and rest of the frames will be moment released. Okay. Currently, it is using the rafter property for the girts, which I would have changed. It's okay, but we can do it in other ways. I will deselect top ones, which already released, only the girts, and assign them with releases, and select them back, and then assign them with the property girts. Now, if you look at the 3D model, you can see the purlins, then the girts, then the columns, and then you have the rafters, right? So these are moment frames. So girts and purlins are released for end moments. Now we have modeled the roofing. We'll also model the vertical claddings of the building for applying the wind loads. So quickly, I can do that with the help of the auto cladding option. So I'll go to the coordinate specification, click on XY plane. I will take objects present in this plane and draw auto cladding and use beams, use selected objects only, then press OK. Right. Right. Next, for the analysis purpose, we'll have to set the meshing, but we'll also have to model the bracings. So for bracings, I'll quickly model them. Starting, I'll apply the bracing, lateral bracing for the Y direction frames, and then for the X direction, we'll utilize this moment frame only, and roof bracing will also be provided here. So to model that, we'll start with elevation 1. I'm sorry, elevation A for the longitudinal direction. So you can see this one. We'll model bracings. There is an option to draw bracing as a quick brace, but it will select the entire story height to model this. Right, this we may not need. So I will use the draw command and quickly draw these manually. For this, I will use a braces. You could have kept it pinned. You can always do this: assign frame releases, previous selection, replicate in other locations, replicate in meters, and in the other side of the building, this auto direction, which should be 16 meters one time. Right. You see the braces are ready. Now for the roof bracing, we'll have to draw because it is a sloped, so you cannot utilize the plane and the grid system to quickly draw, but it is also easy to quickly set building view limits to only the ridge. Right. Draw. We will also use the snap option to line ends and midpoints. For this, it will be the same way. Again, the braces. Start from here. Right. Assign them with releases, get previous selection, and replicate in Y direction for 10 meters. All right. Now we will do one more thing here. That will be the grouping. We'll select all the properties of brace type, A brace, select them and assign them to a group. We will add a group for this braces all. We'll add these selected members to this group. This step is necessary to disengage this bracing for the gravity loading and only present in the lateral loads. All right. The next is the loading on the members. Take another couple of minutes. All right. You can draw cladding, which is a null area object. So currently it is modeled like this. For this triangular portion, you can add them as needed, but I'm skipping those to save some time. This should be okay. Now, one important about this cladding is, so it will take the wind pressure coefficients as a user input, and the automated wind load will be applied to this. Then it will be transferred to the connected objects, and that should apply the wind force for the analysis. So it is completely automated except for the wind pressure coefficient to be assigned by the user. So program is not automated to calculate these coefficients internally. So from the code, you will have to apply this. And for that, we need to know one more important thing. That would be the local axis of these shells. Okay. Let's look at the claddings. And you can see the local axis and auto created, like using the auto option, then its local axis 3 will be perpendicular outwards of the building. It will be helpful in other cases, but for wind loading, we prefer that these are aligned in a same direction for the parallel walls. So what we'll do, we'll select these walls quickly, YZ plane, and the XZ plane. Right, and we'll edit its shell local axis, reverse wall local axis. We'll do this, and it is moved here, but the direction you can see it is changed towards the positive directions of X and Y respectively for all walls. Right. Next, I will define the loading. Then we will give it to the program. Let us start load pattern definition. We'll quickly use wind load definition. So wind loads and seismic loads are automated. So wind loads can be applied simply with one in the orthogonal directions for each orthogonal directions, and then let the program to take care of the reversal also, same as Seismic. But if you want to meticulously apply the coefficients and the wind pressures are varying with directions, then you should model like this, I the load pattern definitions. Wind X positive type wind, you can use this 875, then negative, then Y positive, Y negative, right? And in that, you can set exposure from shell objects. We have modeled the shell objects with uh, the coefficients, which we will apply shortly. The other option, excel from diaphragms, useful for building systems, right? Now to apply the wind coefficients, we have to select these claddings. We'll use coordinate specification and select YZ plane and assign shell loads pressure coefficient, right? So for each pattern, this is positive direction, so I'll apply a windward coefficient, pressure coefficient of 0.8 this side. Now we know loads will be coming from other patterns also for this wall, so I'll use previous selection again, and when it is in the negative direction, we'll use negative sign for this. Previously I used a positive 0.8, it will go in the positive X direction. So it is negative, and it will be a leeward side, 0.2. Next, we will select the other side, and for this negative direction, it will be windward in the negative direction. And for the same, for wind positive, it will be 0.2. Can specify windward, leeward. Windward will have the variation along the height. Leewards will have the constant. Just keep that in mind and can finish this. So let me quickly finish this for Y direction as well. Positive. Y negative, and Y positive, it will be leeward side and 0.2. Same, we'll do it for the roofing. For that, we'll switch back to roof level and you can work in the 3D view. So it will be easier for you to select fish area objects and assign them shell wind pressure coefficient. So Wx positive, you can put these values. I'm using some value, but hope you understand. The local axis will be upwards. Notice, and this is say 0.2. Then previous selection, negative side, say this is 0.4. And for y direction, you can see this side positive 0.4, right? So the directions, if it is having the negative side, then you can use negative sign. All right, this is all we have to do for the wind loading. Now rest is for the program to calculate design wind pressure and apply it as the wind force multiplying with these coefficients. Right. Now we'll also enable seismic. So for seismic, we need to define the mass source. So the mass source we will usually set with the specified load pattern, dead load, then live load, 2.5. Will not lump the mass at the story levels. Can uncheck this. We will define EQX, seismic, autolateral. We'll use an ordinary moment testing frame. Can reduce reduction factor. It will be on a zone 3 for demonstration and give approximate 0.075 h power 0.75. That formula will be used, or you can specify or leave it to the program from the model analysis to get the respective time periods in the directions. One more y direction. One last step would be on the meshing part. We will cover all the meshing quickly. Let me select all the properties, select all the girts, braces, purlins, select them and assign them with frame auto mesh option to do not auto mesh. I'm assuming the bracings are not connected at the center point at the crossings. So we were using this for that purpose. Right. And then we'll select all of these members. You can assign the unbraced length ratios. We can see that once and then we can overwrite it. So I'm skipping this for now. Let's select the last item, which would be support condition. We assume fixed type, the base, and then we run the analysis. Let me just quickly see what happened here. Okay, there is no column. Right. You can see analysis ran fine, and you can see the member forces. Let's start with the displacements. So dead loads and live loads. Yeah, this is expected. Let's focus on the wind. You can see the wind positive. This is for the negative x direction. This is positive y direction and negative y direction. Right. You'll also see for x, seismic and y seismic. So is applied. Right. Right. Now we can proceed with the design, but we want these braces active only for the lateral load case. So for that, we'll have to introduce nonlinear stage construction case, or basically I'm going to convert these. And just before that, I will create the combinations, steel frame combinations, convert to user combinations. We'll keep this so that when I change the load case type from linear static to the stage construction, program may not be able to capture the dead load type in that. So I'm creating this user set of load combinations. Now we'll modify this. Everything remains same except that type now will be nonlinear stage construction. And in this stage, we'll set the stage operations, add all the structures, and then add one more row, which will remove the structure by group, which is braces all. And then add one more row for load objects, dead load. We do the same for the live. We need another 5 minutes to complete this. Okay, now we can run the analysis. All right. Now if I look at the displacement, dead load case, you can see the bracings are not present. Right. As I shift to live, no bracings. Shift to lateral loads, wind, you can see the bracings are active. It is taken care in this. All right. Now we can go ahead and perform the design of steel members. Now, before that, we'll have to review the preferences. Select the code and the framing type. We will be setting it to ordinary moment resting frame. And we can have the seismic code ignored. No, let's consider. And then seismic special load combinations as discussed. We are considering all of these, but you have these settings. To set these, and then we'll proceed with the design. They're automatically selected. Okay. Let's perform the design. Now we have assigned the members as auto select list. So program performs the analysis, and then for the first iteration, it has identified the analysis section is differing from the design section selected. So it is differing, and do you want to iterate analysis and design? Let's give yes. So 14 frames, yes, okay. We will redo the design for one more time, just to show the overrides part. One last time. That could be members be failing. Actually, it is rerunning the analysis and then performing the design. Let's stop this. Right. Right. You can see the red color ones are the members that are failing. But it should be noted that it is because of its effect length factor or the unsupported length factor identified by the program during the design. We will have to overwrite that. The overrides we'll find since many members are selected, it shows varies. Let's enter the design, and then we'll go for the output. It also reports scalar by ratio is greater than, because you can see it is taking the length and unsupported length ratio or the unbraced length ratio as 5. And it is 25 meters in the minor direction, right? You can see this length. Program tries to find these things, but we are providing a shear connection and we want to have this k equal to 1, right? We have this requirement here. And also for the purlins, let's see. It is taking correctly. Length factor is equal to 1, 5, and 5. But in the modeling or in the real structure, it might be providing the sag rods, right, to take care of the lateral bracing. So the lateral bracing can be handled in many ways. One is directly modeling, that is that we are not doing. So we can specify those bracings through steel lateral bracing at precise bracing points. Right? When you're not modeling, but you'll have to specify it, then you can do it with the lateral bracing. The other option is simply overwriting the minor direction effect length factors. So we will do this, and then we'll come back to the design. Last time. So I'll select all the braces, Girts, and purlins, and assign them, design, steel frame design. We have the overrides, view revise overrides, and specify the unbraced length ratio, right, as 1. We'll clear this, and we'll select only the purlins, and we'll provide intermediate lateral bracing at quarter points. Like can provide at for the minor direction 0.25 and 0.25. Right. close this. And for this building, we are ignoring the P delta, but that effect may not be significant. But in the design preferences, right, consider P delta done when it is no. For the moment frames, program tries to calculate the effect length factor as explained in the code that is implemented here, but we want to use it as a non-sway as we provide bracing, sufficient bracings, can convert this to S, or you can also overwrite the effect length factor if you want to. So let me delete and then rerun the analysis, sorry, design below. Yeah, these sections may be differing, yeah, because of this update. Let's do one more iteration. All right. Now, once this is done, you can check. It is displaying the colors first. You can go to the display design info and apply for the ratios. You can see the ratios, remember, and right click on a member to get more details and program designs for all the load combinations and along the length, approximately every 500 mm, sections will be designed. You have access to get at any particular station location you want to review the design results, you can always get it. You can select and go. But when you right click, it shows the maximum one. I mean, it selects the maximum one readily to investigate, get into the details. We'll see the PMM interaction ratio finally found, and it is less than 1, then it is safe. It also checks for the capacities, right? Completely all the information is available to you for each member and each station in that member, right? So overrides directly, there is an override available. This will apply only to the selected member. When we use the design after selecting members, you can directly view revise overrides to selected members, right? That you should remember. We specified this as 0.25. Enter the details. In the calculation, you can see for these purlins, let's use the length factor 0.25 and is 1.25 meters is used. And for the column, it is selected ISMB 225. Right? When you right click, you will also see the analysis section and design section, which can be verified for all the members. Steel frame design, verify analysis, analysis and design sections match for all steel frames. This you can ensure. But sometimes you also need to iterate manually, something like make auto select section null. You can stop this for the members. And then you can also change design section and perform the design alone without rerunning the iteration of analysis and design. And then you can also switch back to the reset design section to the last section. And you found that was okay. And the new selected section is not okay. You can all such options in the interactive mode is available to you. Finally, verify all members are passed always, and then can proceed with the output. So lastly, we also have the display show tables. where you can get all this in a tabular format, design summary and details. But importantly, we also have the material list under the model definition, miscellaneous data, material list by object type or section property, or by stories you can get. Section property wise grouping, we can find. For a quick estimation purpose. All right. So I will stop my presentation at this. Let me have a few questions. If I could answer, I will try to answer them. Okay. So I can read some of the questions directly from here, from the Q&A session. I will try to answer them, or else we will also answer them in a later under the document, Q&A document, frequently asked questions. Okay, how to model built-up column having lacings or pattern. So built-up columns can be modeled using section designer. We have section designer under the frame for this purpose. You can utilize that. So overwrites I have explained. Can we design cold forms? Cold form is not supported in ETABS yet. Currently, it is not available. But you can model, assign, define, assign, and use them in the analysis. Yeah, typically for the pin connection torsion is also released. That's why we do that. And roof beam is connected between upper story, then this will be designed as a beam or base member. Yeah, it depends on the slope, but the design procedure remains the same for the axial and bending and shear forces. So we are using membrane element type to help us in the load distribution, which we need only the load transfer to the purlins. So criteria to check member passing or failing is obtained at the end of the design, final design. You can verify that. We just discussed that. Deflection is checked by the program. For this model, we did not use, but building systems, you need the deflection check. Program performs it for the beams. That result is already available, which I did not discuss. Yes, you can use tension-only members. That is possible. We have the option assign tension or compression-only members, but the analysis case must be of nonlinear type for that. Lateral bracing is very simple. I think I showed you the way we simply use it through the overrides, but you can also assign to the selected members where these bracing points are. That's all, through the option available for that. You can try that and let us know if you have any difficulty on that. Yeah, the design of sections is explained in the design manual, which you can explore. There are quite a lot of things to discuss, but I try to put them on the slides. There might be not sufficient to discuss the design at this stage. We will try to discuss it in detail maybe in another session, but it is well explained in the document provided with the software. So program does not design for Slender members, but you will have to investigate it outside the program. Class 1, 2, and 3. If it is Slender, it will give you a warning. You'll have to check. So yeah, tapered sections are possible using non-prismatic section. We did not cover it in this, given the time. So no auto mesh is given to these purlins and grids because just to ensure these are not connected with any other member, and we are providing these lateral bracing through the overwrites. So just in case for any other member in the model, it's a very simple model, and it is a very straightforward modeling techniques I used. So in a complex model, there can be other member connecting to it or a meshed point will be interfering this. So their program assumes a bracing point. So to avoid those things, it better that we provide it with no auto mesh. That's the reason behind. Yeah, connection design is available in the program, but it is only for US codes. Yeah, hollow sections are possible. You can import hollow sections and use them as any other type. So gantry girder moving load we did not use, but typically it can be modeled with a bracket using a line element and apply the maximum load. But if you want to do an actual moving load analysis, you can do it with a multi-step analysis and get the envelope combo of this, which I think we can discuss it in a separate session, but it is doable for the moving load. For design purpose, you can use the maximum load coming to the bracket and model that and design the columns. Yeah, response spectrum analysis is very similar to the RCC, which we did in the one of the previous webinars. You can refer to that. You can imply that it is the same, and you can do this. But I skipped that to save some time to discuss other things, other important things in the modeling. It's because the modeling is the challenging one, which I wanted to demonstrate that how easy you can do this. I took a lot of time to explain each and everything, but if you do, it may take 10 or 15 minutes to complete this model. And you have the full control on the member section properties, right? Once it is done, then you can simply update these properties and rerun the analysis and design and do the iterations. Yeah, we will share this PPT and the recording soon. I hope I answered most of the questions. Lakshay, I think we can close the session now. We took a bit more time this time. It's okay. I hope. So thank you all for your participation. Over to you, Lakshay.
Thank you so much, Vivek sir, for such an insightful webinar. And thank you so much, everyone, for attending our fifth edition of this webinar. This was just the first one on the steel structures. There will be more. We'll keep you posted. You can follow us on LinkedIn and on YouTube. And the remaining questions and the questions Vivek sir has answered, I'll prepare the FAQ document for that, and the slides, the FAQ document, and the recording of the session will be shared to you in a couple of days. Thank you so much. And if you have any queries, you can email us to at laksha@csiespl.in. And have a great weekend ahead. Thank you. Thank you, Vivek sir.
Thank you all. Bye.
Thank you.